Hey, this is Joe, and today we're going to go through a few examples of completing the square for a quadratic expression, equation, or function. And remember, we use completing the square to move from our standard form to our vertex form of a quadratic. So as a refresher, the first thing you do for completing the square is you factor your a value out of your ax squared plus bx terms. You then add and subtract a particular value within the parentheses. And then one of those values you brought into the parentheses we're going to take out. And then finally you factor with the parentheses to a perfect square. Now if you want to see that process gone over a little slowly, please check out the card in the upper right corner. And so as usual, we're going to go over three different examples. We're going to go over an easy example, a medium example, and a hard example. And for this video I'm going to focus on easy, medium, and hard directions associated with completing the square. So our easy problem is going to have a specific set of directions. Our medium and our hard are going to have different sets of directions. And so really this is going to give you a view into different directions for this problem. So let's start with the easy problem. Let's convert x squared plus 8x plus 3 to vertex form by completing the square. Notice that the value in front of my x squared term is technically 1, and so my a value is 1, and so we don't have to factor a out in this example. We skip to adding and subtracting our special value, which is b over 2a squared. And you add this after your bx term, or 8x. And so b over 2a squared is 8 over 2 times 1 squared, which is 4 squared, which is 16. And so we're going to add and subtract 16 here. Next, I added this step of combining like terms, essentially just combining the negative value we just put in with the c value we had from the start. So negative 16 plus 3 is negative 13. And then I just put parentheses around the other part because that's specifically what we're going to be factoring. And so our final step here is factoring the stuff in parentheses, which in this case factors to x plus b over 2a squared. And b over 2a is positive 4. So it factors to x plus 4 squared. And so x plus 4 squared minus 13 is our vertex form of our quadratic expression here. So let's look at a problem with like a medium level of difficulty. Now let's convert f of x equals 5x squared plus 20x minus 7 to vertex form by completing the square. Notice the only difference between our easy level problem and our hard problem here is that our a value is now 5, and it's written in a function form instead of as an expression. And so, since our a value is 5, or it's not 1, the first step is going to be factoring our a value out of the ax squared plus bx term, which in this case is 5x squared plus 20x. So when I factor 5 out, I get 5 times the quantity x squared plus 4x, where that 4 just comes from dividing 20 by 5. Next, we're going to add and subtract b over 2a squared within the parentheses. And so if we calculate what b over 2a squared is, we get b over 2a squared equals 20 over 2 times 5 squared, which is equal to 2 squared, which is equal to 4. And so we're going to add and subtract 4 within our parentheses. Next, that negative 4 we just inserted within our parentheses, we're going to pull out of the parentheses. And whenever we bring something out of the parentheses, we have to make sure we multiply it by the number out front. In this case, that number is 5. So 5 times negative 4 is negative 20, which gives us negative 20 on the outside. And finally, we're going to replace x squared plus 4x plus 4 with x plus 2 squared. In other words, that 4 value that we added from above completes the square and allows us to factor this specific form. And so the vertex form of our function is 5 times x plus 2 squared minus 27, where the minus 27 came from combining negative 20 and negative 7 from the previous step. And so let's move on to a hard problem. Let's say we're told to convert f of x equals 3x squared plus 6x minus 9 to vertex form from completing the square. This part is the same as our medium level problem. But then we're also told we have to then find the x-intercepts using the vertex form we got. And so let's work on converting f of x equals 3x squared plus 6x minus 9 to vertex form. And so our first step is factoring 3 out of 3x squared plus 6x, which gives us 3 times x squared plus 2x, notice that the 2 here comes from dividing 6 by 3. Next, we add and subtract our specific value within the parentheses, which is b over 2a squared. And b over 2a squared is 6 over 2 times 3 squared, which is equal to 1 squared, which is equal to 1. And so we're going to add and subtract 1 here. We then take the negative 1 that we just inserted within the parentheses out, and we got to make sure that we multiply by 3 when we do that, which gives us negative 3. And finally, we replace the parentheses with the perfect square, which in this case is going to be x plus 1 squared. And so the vertex form of our function is 3 times the quantity x plus 1 squared minus 12, where the negative 12 came from combining negative 3 and negative 9 from the previous step. And so we're now done with the first step of this problem, which is converting the function to vertex form. So how do we then find the x-intercepts using this form? And so the first step is replacing f of x with 0. In other words, we want to find the value of x that makes our function equal to 0, because doing that lets us find our x-intercepts. We then add or subtract our constant to move it to the 0 side. So in this case, since we have negative 12, we're going to add 12 to both sides, which gives us 12 equals 3 times x plus 1 squared. Next, we divide by the value of a on both sides, and so the 3 on the right side here is going to cancel out, and then 12 divided by 3 is going to be 4. Next, we take the square root of both sides, so that on the right side we're just left with x plus 1, and on the left side, the square root of 4 is going to give us plus or minus 2. And we want to get x by itself on this right side, and so we're going to subtract 1 from both sides, and we're going to get x is equal to plus or minus 2 minus 1. And so this gives us two different values. When x is equal to positive 2, I take positive 2 minus 1, and that gives me 1. And when we take the negative 2 on the left side, we get negative 2 minus 1, which is negative 3, and so x is equal to negative 3. And so our x-intercepts have x values of negative 3 and positive 1, and so we can write them in the coordinate form. I have provided written problems to go along with these different difficulties within the description, so check those out if you want to work through some more problems on your own. Otherwise, this is Joe, and thanks for spending some time with me.